Hey guys, welcome back. So till now we have covered 3 chapters of this video course, that is Introduction to Data Structures, Algorithm Runtime Analysis, and the first type of data structure, that is an array. Hope all of them are clear. Now with this video we are going to start the next chapter, that is linked list. So first we'll see what is a linked list and why do we need to learn it. Then we'll see what are the types of linked list and how is it represented in memory. Then we'll see what are the common operations that can be performed on linked list, like create, insert, delete, etc. And then we'll also see which are the application which uses linked list in real world. And finally we'll end this topic with understanding what are the pros and cons of linked list. So let's get started. So first let's see what is the formal definition of linked list. So a linked list is a linear data structure where each element is a separate object. Also, each element, which is also called as node of the list, comprises of 2 items, that is data and reference to the next node. The most important feature of linked list is that it is variable in size. Now I am sure that you would not have understood much from this definition. So let's keep this definition aside as of now and try to understand it using a toy train example. So here we have a toy train which is having an engine and a guard's room. We also have compartments, compartment 1, 2, 3 and 4. Now before we compare this train with a linked list, we need to understand how this train works. So the first thing that we notice is that a train always starts with an engine. It can never start either with a compartment or with a guard's room. The second thing that we see is the guard room is always at the end of the train. It cannot be in the middle or at the start of the train. The third thing that we notice is that all the compartments has been joined using a coupler. So you see one coupler over here, you see one more coupler over here, one more here and one more over here. The fourth thing that we see is in a compartment we typically always have seats and those seats are occupied by passenger. The fifth thing that we see is that all these compartments over here are independent. What that means is, if in case we don't need this compartment, we can always remove it and still the train will work. Similarly, if we want to add one more compartment over here, then we can always add that compartment and the train will still work. What that means is that any of these compartments are individual separate entities and the existence of train does not depends on these compartments. And the sixth and most important thing that we notice about this train is that we can enter any of this compartment in sequential manner. What that means is, if we are sitting in this compartment and if we want to go in this compartment, we cannot directly jump in it. We have to go to compartment 2, from there to compartment 3 and finally to compartment 4. Of course, we are assuming that the train is moving. So these were the 6 common observations from this picture. Now let's see how we can compare this train with a linked list. So if we come back to the definition of linked list, it says a linked list is a linear data structures. Now if we recall from the introduction video, we see that the linear data structure, it is characterized by traversing a data elements sequentially. That means only one data element can be directly reached from a given data point. Now in this example of the train, we also see the same thing. That is, from this compartment, the only compartment which is accessible is this compartment. And from this compartment 2, the only compartment accessible is compartment 3 and compartment 1. We cannot go to compartment 4 directly from compartment 1 without visiting compartment 3. So it is a linear data structure. Now the next thing that the definition talks about is each element is a separate object. So we can see in this train that all these compartments over here are separate objects. Their existence does not matter much to the train. So tomorrow if we remove this compartment, the train will still work fine. So this compartment is a separate independent object. Now the next thing the definition talks about is each element comprises of two items, that is data and reference to the next node. So in this train we see that the data is nothing but the passengers sitting in that compartment, and the reference is nothing but these couplers which joins two compartments together. And the last thing which the definition talks about is list is always of variable size. That is, we can always remove some of the compartments or add some more compartments depending on our needs. So now that this train has satisfied all the properties of a linked list, we can say that this train is a linked list. So now that we have understood what exactly is a linked list using a train analogy, let's try to see how does the linked list looks like in computer science world. So in the world of computer science, this is how a linked list looks like. So we have an head and we have multiple nodes over here, which is nothing but the elements of a linked list. And then finally we also have a tail over here, which always points to the last node in the linked list. Now if we compare this list with the train example, there is a striking resemblance between them. So here we had an engine which drives the entire train. Here we have a head which drives the entire linked list. Here we had compartments which had data or passengers and a coupler which was joining two compartments. Similarly, here we have nodes which is having value. In this case we have 10, in this case we have 20, and we also have a coupler which basically joins two nodes together. And finally we had a guard room over here which typically is always at the last of the train. Similarly, we have a tail over here which all the time points to the last compartment or node of a list. Now how do we insert new nodes or remove existing nodes, and what is the use of head and tail? All those finer details, we'll talk about all of them in the later videos. Now that is all for this video. In the next video we'll talk about how is an array different from linked list. Thanks for your time. See you in the next video.